What if our greatest triumph is also our greatest illusion? Our reach into the cosmic tapestry, boundless as it seems, is tethered. A mere 380 seconds of specific impulse from chemical rockets. This is the invisible chain. It demands an orbital ballet so complex, so vast, that for a Starship to venture beyond Earth orbit, it needs 10 to 12 tanker launches. This is the reality. This fragile, unproven scale of our current deep space ambitions exposes our astronauts to heightened cosmic radiation, to the insidious stresses of the deep void itself. But there is another way. A promise whispered from the heart of the atom. Nuclear thermal propulsion shatters these limitations. It promises over 900 seconds of specific impulse. A methane-based system alone achieves roughly 625 seconds. This isn't just an improvement, it is a profound leap. It enables direct moon missions, eliminating the need for an entire fleet of refueling vessels. This power reduces propellant for a 138-ton dry mass Starship, allowing it to carry 25 tons of payload and return with 520 tons of methane. It also delivers continuous, high-density electrical power, far surpassing solar panels in the deep void or the shadowed regions of the moon, supporting life support and long-term outposts. Yet, this very power carries its own cosmic calculus. The nuclear system, launched safely on chemical rockets, is only activated post-orbit. It employs a shadow shield, tungsten for gamma, boron carbide for neutrons, further augmented by distance and the methane propellant itself. Even the digital core of the spacecraft adapts, triplicating on-board computers to manage bit flips with a best 2 out of 3 logic. Here is the cost. This methane-based nuclear Starship faces a potential increase to 191 tons dry mass. It demands stronger structures, tighter margins, and a nearly 1-month turnaround for reusability, due to decay, heat, and radioactivity. A stark contrast to rapid iteration. As we reach for the stars, the journey within the cramped confines of our vessels is equally brutal. The hell of older microgravity waste management. This is how veteran astronaut Shannon Lucid described it. In the cramped, privacy-bereft Soyuz, under 3.5 cubic meters, it underscores a fundamental, intimate challenge. SpaceX Crew Dragon confronts this existential discomfort head-on. It simplifies the process with airflow and suction for solid waste, vacuum sealing and rapid moisture removal to suppress bacterial activity and odors. Liquid waste is managed with gentle suction through anatomically considerate funnels. NASA explores water recovery from fecal matter, and current canisters burn up in disposable cargo ships like the Russian Progress vehicle. Unlike the manual, often messy procedures of older systems like the Russian ASU or Space Shuttle, which required twisting and sealing bags by hand, Crew Dragon integrates a distinct, retractable toilet near the top docking hatch. This optimizes precious capsule volume. It improves professionalism. This evolution is hard-won. The ISS faced a 2008 gas-liquid separator pump failure, forcing hands-on collection. An STS-46 fan malfunction required in-flight maintenance. SpaceX itself redefined its system after an Inspiration 4 leak from a partially detached urine transfer tube, replacing bonded joints with a fully welded structure for continuous connection. The cosmos demands perfection, even from our most intimate systems. As we strive to transcend the frailties of our biological forms in its indifferent embrace, we find ourselves in an endless negotiation. A negotiation with the void and with ourselves. If our very journey out depends on such agonizing precision for the most basic human need, what other hidden imperfections await us, just beyond the edge of our knowing?